Okay, going to have a look at 2014. We've got two questions. Question 4 and question 7. Question 4a. Y equals x cubed minus 6x squared, add 12x minus 8. Differentiating that, you get 3x squared minus 12x, add 12. Part 2. You want the turning points. So dy by dx equals 0. So put that equal to 0. So 3x squared minus 12x add 12 equals 0. You can divide everything by 3 because it equals 0. And that makes it a little bit easier. Factorise what multiplies to give positive 4 and adds to give negative 4. So it's minus 2 and minus 2. So x is 2. So you have got one turning point. You need to find the nature of that. So I've got to do my second derivative as normal. Here's my first derivative here. Differentiate that again and you get this. At x equals 2, your second derivative works out to be 6 times 2, take away 12, which is 0. This is called the point of inflection. Now, when you have a point of inflection, this doesn't come up very often, but it's a good idea to test it either side. So what I mean by x is 2. So I'm going to see what happens when x is 3. I'm going to see what happens before it when x is 1. So let's see what happens to the gradient. After it when x is 3. You put it in here. So 3 times 3 squared is 27. Minus 12 times 3 is 36. Add 12 and that works out to be 3. So it's a positive gradient. What happens before the turning point when x is 1? So putting x equals 1 in there. So it's 3 times 1 squared minus 12 times 1, add 12, it's 3. So they are both positive. So this means it's a positive point of inflection. So what it means is it's starting to go up. That's it, the point of inflection there. So the two turning points merge into one at that point. Part B, you've got fx. So let's fix it up. So it's 4x add x to the minus 1. Differentiate that, you get 4 minus x minus 2. You want an increasing function. So it's increasing when the derivative is bigger than 0. So that is 4 minus 1 over x squared is bigger than 0. To help solve that, I would multiply everything by x squared. I want to find it's a quadratic inequality. So I need to find the critical values. To find the critical values, you just put it equal to 0 as normal and solve. This is the difference of two squares. So put in each bracket equal to 0. Now back to the quadratic inequality. So if you can remember those are the ones we have to draw the wee graph for. So it's a minus a half and a half. You want above the graph. So I'm above the graph, above the x-axis I should say. Here and here. So x is under minus a half or x is bigger than a half. Make sure it's nice and clear there. And the last question, number 7. Differentiating it, dy by dx is minus 2x to the minus a half, add 1. You're told that x is 2. So let's work out the gradient. So it's I'd write that as minus 2 over root x, add 1. So the gradient is minus 2 over root x, add 1. I want the normal gradient. So normal gradient is minus 1 over your gradient. So it's minus 1 over this rigmarole. I'm adding in the bottom line, so I wanted to make it look like two fractions. So that's 1 over 1. I want both bottoms to be root 2. So multiply this bottom by root 2, so you multiply the top by root 2. Once the bottoms are the same, you can add the tops here. So it's minus 1 over minus 2, add root 2, all over root 2. 1 over a fraction means you turn it upside down. So that root 2 comes up, and the bottom line is going to write a bit neater. I'm going to write root 2 minus 2. You need to rationalise the denominator now. So it's minus root 2 minus 2. Remember, multiply it by the reverse sign, or reverse one of the signs, I should say. Timesing out the top. Minus root 2 times root 2 is a 2. Minus 2 root 2. All over. The bottom line becomes 2. The roots disappear. Minus 4. A lot of minuses going on here. So what I'm going to do is going to factorise out a minus 2 of the top row. It will then cancel with the root 2 in the bottom row, leaving you 1 add root 2 as your final answer.